Like, sure, just wait a minute. To send some paper. Hmm? Hi, Dr. Radu.
Hey, how are you?
Yeah, it's good.
Can you hear
Thanks.
me?
Yeah, yes, yes.
Okay, okay, everything okay?
Yeah,
You
yeah,
you're able to talk to me like 15, 20 minutes?
yeah, yeah, yeah. I'm ready. Yeah,
Okay. All right. All right. Okay. Yeah. So I want to talk to you like 20 minutes or so. We'll not talk half an hour. I just saved half an hour, but I really meant it to be shorter.
yeah,
So yeah, I came across your file and it looks quite interesting to me, particularly the kind of projects that I have in mind for the next year or next couple of years. So tell me a little bit about yourself, right? So forget about resume, forget about CV, everything. Just tell me about yourself. Why are you interested in a PhD? What do you want to achieve in life? Whatever.
okay. So yeah, to be honest, I really like about the researching. So yeah, in my first step in the research with my
I'm sorry.
yeah. So yeah, in the undergraduate program, I think it helped me to know about the research, but I think it's not enough for me. So I need to like find another environment that higher. I think it could be higher, so I can improve my research skill and also like to try new things. Because
Mm-hmm.
I think like a milestone step of mine that make me feel like very fascinating that I have a chance to be a research assistant in the Taiwan. So yeah, when I first go to the like other country, I feel very like open-minded and like it's like help me like to step out of my comfort zone. So yeah, I think yeah, and now I think uh, pursuing a PhD can help me like to know about to know more about the world. Yeah, and also like I can have a chance to like exchanging a different culture in many countries and also about mm, yeah,
Okay, I got it. Okay, so you're essentially a research
yeah,
person and you want to become a researcher.
yeah.
Okay, so speaking of this, so what do you want to achieve with this PhD? Say, if you finish the PhD tomorrow, what will be your ideal
Yeah,
continuation of that?
yeah, I think I want to become the research scientist and working in the national lab or national institution. Yeah. Mm,
Mm-hmm.
because yeah, because when I was not really, but when I was young, I have seen a lot of movies about the scientific and make me feel very like interest about it, and I because the research that they do that make me feel like I can contributing I can contribute to the world like that. And yeah, and so yeah, it's just like uh, some motivation that make me like want to pursuing PhD program. Yeah.
Okay. Um, so tell me about your strengths. I'm
Strength.
not I'm not referring to grades or GPA or whatever. What are you good at? Imagine we meet in a airport
Hmm.
and I'm asking you what do you do for living? And you say research. So then I'll ask you, okay, what are you good at, right?
Okay, so you can see that my background is about computer science. So yeah, I think I'm very good at coding. And besides, I also know about the research flow that we need to when we want to find like a research question, we need to like
Mm-hmm.
mm, we need to like first we need to read some we need to explore about it first. So like we should like have the research topic first. So
Mm-hmm.
in this research topic we like explore about it. We will spend most of time to explore about it. We need to know everything about it. We need to find some benchmark and test on it, and find the problem consist find the problem existing in this topic. Yeah. And then when we have then we find the problem, and then we propose a research question, and based on this research question we will also like to explore about the method that can address this problem. And
Okay.
yeah, anything
Yeah.
yeah, anything my
Keep
strength
going.
about the just about the researching and coding. Yeah.
Okay. What are you not good at? What's a weakness? Or
Yeah. To be honest, I think my weakness is about the presentation, and yeah, because I'm not very good at the social skill. Yeah, so I try to improve that, but I think now I think communicate well, but not too well to make everyone to understand. But yeah,
okay.
yeah,
Yeah, typically PhD is the perfect place to improve your communication and your presentation skills because you have to do so many presentations that after a year or two you become really good at doing it. Okay. So, and you said your background is in computer science.
yeah,
So, can you give me an example of topics that you studied, like in computer science? I assume algorithms, right? And
yeah.
how
Uh,
about computer vision or?
yeah. I think most of my research experience will focus on the computer vision. So you can,
Okay.
yeah. So you can see my series are just about the medical image analysis and some topic related to the image segmentation. Yeah,
Mm-hmm. Okay. Now, um, so let me ask you something more around this. So, what's your most relevant experience, you would say, or project that you are taught you? So, you said is in image segmentation.
yeah, yes,
Okay, so I see you have some great papers here, like Mikai and ICASP and whatever. So, which one will be the most representative two papers I should look at
yeah.
to
The
from your list?
the first paper you can see that about the uh 2H match on the CMIG, and the second is
Mhm.
about the adaptive knowledge transferring that purpose in the
What paper is that? Is paper four?
MIDL 2025. Um,
I see pattern recognition journal. Is not this one?
uh, Pattern recognition is just on the revision, so yeah, I'm not mentioned about it, but yeah, you can ask, you can
You
see.
have it in your CV. I'm looking at your CV.
Yeah, Yeah.
So which one? The first one you said, or I misunderstood you?
Uh, yeah. You said that I need to choose paper, right? Two paper, and so the first paper is published on the CMIG journal, and the second, um,
No, the first paper in your publications is the MIDL 2025.
yeah, yes, yes, yes.
Is not that one, or which one? So I'm sure there are good papers, but which one would you want me to read so I understand your strengths and
About
your
the 2H mark, can you
uh,
verify this?
do it match paper number 5?
Yeah, yes.
Okay, okay. And
And the first paper, the
first paper, semi-supervised skin lesion.
yeah, yes.
Okay, I'll look over this in more detail. Okay, so yeah, I saw that you also have a lot of collaborations with the people
Professor.
outside your institution, like CMU and Pitt and North Carolina. How this all these collaborations came about?
Yeah, I just like take a chance with this with CMU that I know one guy, and he's helped me to uh help me to connect with Professor Minsu in CMU,
Mm-hmm.
and
Mm-hmm.
and based on that experience I try to just uh try to connect by email them. Yeah.
Mm-hmm. And how long did you work on these projects, like these collaborations?
Some collaboration I ended a long time ago, not too much longer, just a few months ago. And I think
But
yeah, but
go ahead.
uh, I think I'm still working with Professor Mingsu in CMU, and now I also
Mm-hmm.
like collaborate with Professor Ulas in the Northwestern University. Yeah.
Mm-hmm. So in Northwestern, you also knew a guy, or how did you connect to them?
Yeah, we I just connect just with him also by this guy because we because we work in like a group, and we will have a leader. Yeah, so this guy will help us to connect with other professor, and and our work like to try to collaborating with them in some project. Yeah.
So this person is a student at your university. When you say this guy, who's this person? I don't understand.
Yeah, you can see in my paper that I always like co first author with a
Uh-huh.
person. Thanh Huy, you can see him in two paper.
Who's the person?
Uh, Thanh Huy Nguyễn, Thanh Huy.
Oh, okay. So TH Nguyen.
Yeah, yes, yeah.
Oh, okay. So, but I see all these are brothers or what? Because I see, for instance, in your second paper, you have TH Nguyen, you have TH Nguyen listed again. I don't know, it's a duplicate or what?
No,
Or
no.
is a different person?
Because my name and his name like similar. My
Uh-huh.
my name can be like shortened like a T, but his name can be shortened as TH. Yeah,
Oh, okay. So it's two different people.
yeah.
And he's a student like you, or is a professor or what?
Yeah. He just master student. Yeah,
Oh, the TH.
yeah,
Oh, okay. Okay. Yeah, it's unusual. That's why I'm asking because you worked with two or three universities already,
yeah,
even before you start PhD, right?
yeah, yes.
And that's why I'm asking. Actually, four universities. So that's why I'm asking. It's a little bit unusual. Okay.
Yeah.
So yeah. So I don't know how much you know about my projects. Um, and let me ask you a different question first, and then I'll go back to this project thing. What will make you come at UT, say, to work on my team with this?
Um.
Because you already seems to have already uh, uh, this long-term collaboration. I mean,
Yeah.
quite significant collaboration with these people. So what will make you come to UT, say, compared to CMU or compared to
Yeah.
Northwestern or to whatever? I'm curious.
Mm, yeah, because uh, to know about YouTube, it's just like find your name in the scholar, and when I have a check on your website, I think I saw that you have some topic related to medical image analysis, and when I have a check on your publication, I see that you have a lot some paper related to SAM and also about the
Mm-hmm.
medical image analysis. So yeah, and this is also like the topic that our group, uh, not I and our group try to explore now. And yeah, I
Mm-hmm.
think this yeah, I think this is a great opportunity that let me to know you. Yeah.
Okay. Yeah, let me tell you a little bit about my projects and how my projects are different than these two other people. By the way, I don't know if you know, but I was 20 years professor at CMU in the EC department. So I know very well that school. Uh, uh, I was professor at CMU between 2000 and 2020. So I spent most of my career in CMU, so I know very well the departments there, and I collaborated with people in CS, and I worked 4 or 5 years in collaboration with some people from the bio side. I worked on some stuff modeling bacteria and different type of interaction in multicellular organisms and this kind of stuff. But here at CMU, what I'm trying to here at UT, sorry, what I'm trying to do is I started with this medical imaging first 2D, and now I extended to 3D with a few recent papers. But I'm trying to build a bigger project which will bring together multimodal continual learning, computer vision, and biomedical imaging. So I'm trying to bring these three things together, and I'm collaborating with three doctors, or three and a half, I should say. One is in the cancer, colorectal cancer area. One is in brain, is a brain surgeon. Another one is in ophthalmology, so basically images for eye, and that comes from a different imaging modality, OCT. You probably might have heard of it, right? The OCT that is used primarily for retina and other things. And also someone from the pediatric neurology, which is a new project I'm trying to start that involves primarily time series and EEG type of signaling. So there are these different modalities that you could see from this discussion, and I'm trying to create, how should I say, models that are meant to be very efficient, meaning to enable imaging on tablets or cell phones or whatever, and also trustworthy. So because of that, the angles in my group are centered around efficient AI, medical AI, and trustworthy medical AI. So just to explain a little bit this trustworthiness angle. So the current research, I have a couple of papers under submission, um, are bringing formal methods from computer science, like from automata theory and that kind of stuff, computational tree logic and this kind of things. And we try to guarantee both spatial and temporal constraints in video. For instance, when I mean video, spatial, just imagine you take a video and you have a character and
Yeah.
you want to say, well, I want to make this lion a dog,
Mm.
a blue dog, right?
Mm.
So say this line appears in 3 frames, 77 in a video stream. So say 77, 85, and 92. Well, I want to make sure that that specific lion is transformed into a dog very precisely, such that it cannot be even observed, the transformation. But that's the spatial dimension. But the temporal one is that we need as I said, is very specific frames, not like 76 and 77, but only 77, say, right? So that's why we need these formal guarantees in the form of temporal guarantees to make sure that uh, uh, the substitution or the extraction is very precise, or the transformation is very precise. And obviously, I want to do this in real time, meaning it should be very efficient. I don't want to do it post-processing, right? You have the video, you take it off, you do the editing, and you put it back, right? I want to be able to do it very efficiently so it can be done in real time.
Yeah.
And as you can imagine, this could be crucial for medical AI when you may want to see, okay, say, show me what happens if we remove this part of the spleen, or what happens if we remove this part of the colon and whatever. So that could be, if it's done in real time, it's very useful during surgery as opposed to post-surgery, right? You know, and you analyze the images post-surgery and all these things. So that's one big direction. Again, it's about video medical AI processing in real time with spatial and temporal constraints, and aiming brain or other internal organs like colon and whatever the gastroenterology person may tell you as being relevant to them. Another project that is I'm trying also to grow here is about these multimodality transformations. You know, there are multiple modalities of transforming. Say you can use a T1 image or a T2 image or whatever. So the idea would be here to see what we can do with one imaging modality that could, in some cases, substitute very painful and very time-consuming procedures when you want to extract a different modality. So that's why the multimodal continual learning is a big topic in my group, and I plan to do it. In fact, I do have two distinct directions. One is for general video generative AI type of approaches, and one is aimed at medical AI. So this year I'm planning to grow particularly the medical AI. That's why I'm planning to hire 2 students for this, such that I can create more momentum in the group and to do something. Besides this, I have another project which is on still on the medical AI, but is on the system side, meaning wearables, batteryless AI. So essentially, when you don't have any batteries and you use solar energy or movement energy and this kind of wearables, and you try to monitor different parameters, for instance, for training purposes, for recuperation purposes, and so on and so forth. So this is kind of complementary, but in the big picture adds to the same ecosystem that I'm trying to create here.
Yeah.
Does this make sense to you?
Yeah.
I mean, it gives you a good image. So if you join my group, you will collaborate with people working on video side of video editing, continual learning, catastrophic forgetting, whatever, but also with people who specialize this type of approaches specifically for medical imaging, because some of the things are common, but some of the things are very different. So that's why I'm trying to keep these 2 directions and to work on this. And as opposed to what you mentioned in, say, Ulash group, I know him personally, by the way.
Oh.
So the guy at Northwestern. What's different is that in our side, the angle is first and foremost computational, because he's in the radiology department, I'm in the computer engineering department. So our emphasis is more on the algorithmic side, complexity, efficiency, and this kind of concerns. Like I have constraints, like for instance, for me, a model is good, but if it works on a cell phone or on a tablet is a lot better than if it works on a big device that has gazillions of GPUs and whatever. Because for instance, if you think about emergency medicine or critical care or emergency care, whatever you want to call it, those kind of devices are not available, in small units, remote units, in hospitals that are not super powerful and super well equipped with this kind of resources.
Yeah, that's true.
That's the difference, and I'm coming primarily from the computational angle, and for me, efficiency is a topic that I worked on for over 25 years. The focus for medical imaging is recent, but my entire research, if you look since 2000 or even 1998 was focused on efficiency, like low power design for computational systems, then wearables and things of that nature in more recent years, and then now toward medical imaging. The efficiency angle in medical imaging is relatively new, and still people don't appreciate it as it should be. But I'm pretty sure that 2, 3 years from now it will be very different because all these radiologists and whatever have not Ulas in particular, everyone. I was at Mikai, they have no clue about what they mean. They have billions and they think the bigger the model, the better the results, but it's not like that. So
Yeah.
in my group, you'll have also a focus on this kind of constraints that are either memory constraints,
Mm.
could be, or could be low power constraints, because if you have a device and you try to image something, right, and the battery runs out, is no good, right?
Mm.
So on and so forth. So it's a broader angle and a broader approach to this important problem, whether or not it's image segmentation or or object recognition or image reconstruction or whatever. And I plan to go into all these areas. So my project for this is pretty big and ample, and I hope to get at least 2 people this year and maybe 2 next year to grow it into a more significant part of research. Okay, all right. So yeah. So I don't know. Do you have any other questions for me? So you still didn't answer. What will make you come at UT?
Uh, Sorry, what? Can you repeat the question?
What will make you come at UT versus, I don't know, Northwestern or versus CMU, whatever? I'm trying to understand.
No, because I come to the UT because I know you.
Oh, okay, because of the project.
Yeah.
Okay. I don't know how much, since I brought it up, I don't know how much you know about UT. It's a great place, particularly in bioimaging, because we didn't have medical school
Mm.
until 8 years ago, I believe. So once they established a big medical school, Dell Medical School is called, these days there is probably the biggest effort in bringing together engineering school to work with people in the medical school. Hence all these collaborations I started with 3, 4 doctors. And this is going to go even bigger. This year was the year of AI at UT. So basically, everyone was trying to see how we can leverage AI in the medical domain and change things for the better. And in the next few years, will be even a bigger emphasis on this. So will be a lot of opportunities to bridge the uh, bridge the engineering part of the story with the medical part of the story.
I know that in the UT system, there's still like many school that focus on the medical imaging like that. So do we have any like collaboration between school in the UT system?
Yeah. I actually had a little bit of collaboration, which I may grow now with the. That's how I got familiar with the OCT, with the medical school at UT San Antonio, which has a. But that was in the cardiology department. So I'm exploring this now with another doctor in the eye in the ophthalmology department, because OCT is also used. Actually, it started there in the 90s, right? So it's there are a lot of interesting things at the connection eye brain, and basically this looked to me a little bit more interesting than the cardiology side, which is very important too. It's a different type of imaging. Yeah. So there are a lot of collaborations here, and UT is in a perfect place. Austin has a lot of companies, a lot of even medical companies, startups, and everything. Is a very active. Is probably top 3 ecosystems in the country in terms of startups and small companies that work in the medical domain. So it's a very interesting area
Hmm.
to try to go these projects, because we have here all the big companies here, like Meta and Google and whatever, but we also have a lot of companies like, I don't know, Silicon Labs and all these things that do small things for wearables, for mobile devices and whatever. So it's an interesting problem space.
How about the national lab and national institution, like in the cancer institute or like in
Yeah, yeah. As I said, the collaborators that I work with are in the cancer angle, meaning oncology department, and this has multiple branches, from ranging from problems in bioinformatics, like medical records, all the way to problems at molecular level. So it's a very broad problem space, and
yeah
a lot of doctors at different levels, as I said, from molecules all the way to electronic record management and bioinformatics and
yeah
anything in between. So there is a lot of opportunities, and it's continuously growing, which is important.
yeah, that's right. Mm.
Okay. Yeah, I'll if you have any other question, you can email me. I will look more carefully over all these documents and everything and let you know pretty soon if I'm able to make an offer, and then we'll go from there. Sounds
Yeah,
good?
yeah.
All right. Very nice talking to you,
Oh,
and
uh,
wish you all the best. Okay.
so if I have some
Yeah.
question, can I like
Yeah, yeah,
uh,
email me. Yeah, email me. Yeah. Okay.
yeah, thank you. Yeah, thank you very much.
Nice talking to you. Bye.
Yeah, bye.